Right triangle ABC has leg lengths AB equals 20 and BC equals 21. So the right angle is at B. I'll draw this to scale. B, A, B, C. Triangle, so right triangle ABC has leg lengths AB equals 20 and BC equals 21, including AB and BC. Including AB and BC, how many line segments with integer length can be drawn from vertex B to a point on hypotenuse AC? So if you visualize it, the length of the segment is largest when it's at AB, and it slowly shrinks. It gets shorter and shorter and shorter and shorter, and it reaches its shortest point when it is the perpendicular, and then it gets longer and longer and longer and longer and longer and longer. The reason why is this, when you drop the perpendicular, why this is the shortest is because the purple line is longer than the red line, since the hypotenuse is always the longest side of a right triangle. All right, so that means that so we're trying to find integer lengths. So what we really care about is the bounds, like what's the lowest possible length of the line segment, and what's the highest possible length of the line segment, and then all integer lengths in between there we can just hit as we go. So we denote this point being as D, and it is of great importance to us to find BD. And how do we do this? Similar triangles. Just gonna label that. I find this helpful. Okay, so whenever you drop a perpendicular in a right triangle, that always means that you have some triangles. A triangle ADB is similar to triangle ABC. We want BD, and we have AB, so AB, so BD over AB is equal to BC over AC, so BD equals AB times BC over AC. Nice and symmetric. And if we substitute this in, this is in fact equal to 20 times 21 over the square root of 20 squared plus 21 squared. And we want to find like what's the smallest integer that's bigger than this, because like that value is going to be the shortest line segment that we can achieve, and we can put it on both sides. And unfortunately, square root of 20 squared plus 21 squared is not easy to compute. I don't think so, at least. Because that will end up being like 841. 29 squared is this is 29. I forgot about this. Okay. What a lucky coincidence. I don't know why this keeps happening. Okay, so the hypotenuse actually is length 29. And so we can find, we want the smallest integer length that's like bigger than that. So we do 420, which is 20 times 29, 20 times 21, divided by 29. And that gives 14. Yeah, so 14 is the amount that divides in. So the smallest integer that is greater than BD is 15. So on this side, we can get 15, 16, up to 20. On this side, we can get 15, blah, 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 up to 21. So there are 6 on the top side and 7 on the right side for a total of 13 different integer lengths we can hit, which gives 13. Answer D.